Welcome also from my side. I hope you can hear me okay. I'll talk a little bit about tools and software we'll hopefully use this week. But before that, I would like to briefly introduce myself. So my name is Johannes Signer. I'm based in Göttingen as well at the Department of Forestry, and I'm working as a scientist in the Department of Wildlife Sciences. I have a background in ecology, GIS, and statistics. In terms of research, my main interests are movement ecology, which isn't the topic here today, but also I'm very much interested in statistical methods, quantitative methods in wildlife sciences or ecology in general. You probably already saw at the beginning there were quite a few icons, so maybe you can see it better now. So what I would like to know from you is which icons do you feel familiar with? And you could either go to menti.com and enter this code, or you could just scan this barcode with your smartphone and just click on each of the icons if you know what is behind that and you feel somewhat familiar with that. Okay, somebody already started. And I'll give you maybe 30 seconds. Okay, very good. So most of you feel familiar with R, which is here, and that's good because we're not going to talk about R very much. So we targeted that right. No one feels familiar with that. That's probably also because this icon is not very intuitive. That's Quarto. That's a markdown engine, and it's also integrated to R. We'll talk about that a little bit. Quite a few of you feel familiar with Python. Not so many with Jupyter. That's one of the main topics for today. Quite a few feel familiar with GitHub here. And I'm supposing that all of you who are familiar with GitHub also are familiar with Git, which is this icon. Not so many people feel familiar with the terminal or the bash thing. We'll use that today to interact with Git from Jupyter Hub. So the plan for the next 90 or 80 minutes is that I'll give you a brief introduction to Jupyter, Jupyter Hub, Jupyter Lab. That's this part here. Then also how you could integrate Quarto into Jupyter. And obviously Jupyter comes with Python and R. The second part will look how we can link our Jupyter Lab to GitHub. That's here. And of course, we need Git for that, and we need the terminal for that. I would encourage you to try things as we go along. Usually, I would say if there are problems, please interrupt and we'll try to solve that. But I think today there might be quite a few problems, especially with the Git part. So if there are small things, we can still try to solve them, but probably we need some one-to-one sessions afterwards or later during the week to solve everything. And the time is somewhat limited. So if you get lost somewhere on the way, that's okay. You could always post to the Slack channel. I'm not sure, Daniel, I missed that this morning. Did we encourage participants to post to the Slack channel or not? No, maybe. Did we encourage people or participants to use Slack, or is it that just for the lecturers? Not yet. Okay, so then post it just to the normal chat. Ignore that. Sorry. Okay. Why should you use FAIR tools? I think Ivo gave a great introduction the last hour. And one of the very obvious reason is you could provide your code using repository. GitHub is one of them. There are many others. We'll use GitHub here because it's quite convenient and very widely used. Then you could provide your execution environment, and that's another set of tools. And I believe that's the topic for tomorrow, where you could not only provide your script, but your whole environment where your scripts were executed. Tools for that would be Conda or Binder. And finally, you could also provide your workflows in a nicely documented way, or you could build your publication, report, whatever, based on a reproducible workflow. And that's, again, Jupyter or Quarto, which would be the tools to use. So let's get started and have a look at what Jupyter is and does. A Jupyter notebook is basically nothing else than a text file. And Ivo just said in a previous lecture that text files are a good idea. They're very open. They're very interchangeable. And a Jupyter notebook is a JSON text file. JSON is a JavaScript object notation. That's a specific way how to structure a text file. And the Jupyter notebook ends with the suffix IPYNV. So the I stands for interactive, PI stands for Python. That might be a little bit misleading because by far Python is not the only language that can be supported by Jupyter, but it comes from the Python world, and NB means notebook. So basically what you have is a text file like this, and I think in 99% or even 99.9% of use cases, you will never interact with that text file directly. What you do is you run Jupyter on a local instance on a server, and then you can interact with your code through your web browser. How that's all working, we'll have a look at right now. Before that, I wanted to clarify a few terms, and I hope that makes life easier. I had to get my head around most of them as well. So a notebook, that's what we just talked about, is a JSON document. JSON is just a way how to structure a text file. And this JSON document is rendered in your browser. In this document, you have different cells. And the cell is the most fundamental unit of a notebook. And you can have 3 types of cells. I only listed 2 here, but you can have markdown cells, you can have code cells, and there's also a special type called raw cells, which we don't worry about today. A markdown cell is a cell where you can provide structured text. And I'm fairly sure most of you have heard about Markdown, R Markdown in one way or the other. A code cell is a cell where you can put executable code. For example, you can put R code, you can put Python code, you can put Julia code, you can put any other code. And then we have a kernel that's running in the background, and the kernel takes the code from your code cells and executes that code. So, and all of that is put together in a Jupyter notebook. And then you have the instance where you have multiple Jupyter notebooks. You have also maybe a folder with data and so on. And that's what then is called a Jupyter lab, like a lab book, or where you have everything together. And then finally, there's a Jupyter hub. And that's a server that serves many Jupyter labs for many different users. So you have been provided by Daniel this morning with your access code for the GFBio Jupyter Hub. So you can go there, and each of you can go there and have their own notebooks or their own Jupyter lab and work there independently. So how does the architecture look like? So you could start here. That's us. This is the client. We want to work with Jupyter. And Jupyter is hosted on a server that could be locally or remotely. Then there is a text file, that's the notebook file. And then there's the kernel. So we interact with the notebook via the server, and the server then interacts, or the notebook interacts with the kernel also via the server. The server, as I said, could be locally or remotely. Locally is you have to install some programs on your machine. Remotely means that somebody else does that for you. And often big organizations, I know like the GFBio has a remote server, Also, I know from my university, the GWDG hosts Jupyter instances. So then you don't have to worry about setting up the software, you can just use it. As I said before, the kernel, this is the instance where the program is actually being executed. And there are many different kernels. The most popular are, of course, Python, R, and Julia. And then here again, this is the notebook file, which is just a plain. Okay. So which languages does Jupyter support? I just said it before. It was originally designed for Julia, Python, and R. So you can find this acronym somehow in the name Jupyter. But since then, it has been very popular, and there's a long list. I found that on GitHub of more than 50 languages that are being supported by Jupyter. So some are probably more experimental than others, but there's a huge community behind that. Okay. That's what I also mentioned before. We can have two ways to run Jupyter, locally, remotely. For this course, you can go in a minute to the Jupyter Hub hosted here. Or if you want to do that yourself, you can install an instance locally. There are some instructions here. We're not going to go through that here. So once you're there, the important thing is that you look again here for your username. For me, it's Johannes Signer. For you, it's student some 1, 2, 3, whatever, and click on that. So if I click on this, I already have some, I didn't clean it up, so there's some parts in here. But the more important or interesting part is this part here. It's called a launcher, where you can open different notebooks. You can open consoles, and there are other things that you can do. And if you want to open a notebook, you just click here on an R or on a Python notebook. So what's the difference now? Here, and you see it, it's an interactive Python kernel. Here, you get an R kernel. And remember, the kernel is the programming environment where your code is being executed. So if you click here, for example, on R, that's what it looks like. So we just did that. You click here to open a new notebook with an R kernel. And now you can navigate through your notebooks. So there are a few commands on the command line or on your keyboard that you can use. You can also do everything visually. So there are two different modes. That's something you may or may not be familiar with. So there's a command mode and an edit mode. In the command mode, you can navigate around cells, and in the edit mode, you can actually manipulate cells. So I have an instance here. It's an R instance, and here that's a cell. And you can say here it's a markdown or it's a raw cell, a code cell. By default, it seems to be a code cell. I put that as a markdown cell now, and now I could write like first heading, and here is some text. And if you execute that, so I'm hitting command and enter, or you just hit here, execute, and then you see it's being rendered to something fairly nice and easy. Now, the second idea is that you could have a code cell, and most of you are familiar with R, so that's nothing that surprises you. Probably you create a vector, assign it to numbers 1 through 10, and you output that vector. And if you run that again, so you see this code is executed here. And then you could add another markdown cell here and say, now let us create an image, for example. That's kind of documenting what you do, and you add a new cell. Now added one on top. I want to add one below. So we have here a new code cell, and we could say now you just plot these numbers 1 through 10 here, and if you execute that, what you get is you get a plot, and that's everything is rendered in there in your kernel, right? So I hope that this worked for some of you. For those who had problems doing that, please just try it again later. I guess midnight is probably a good timing when everybody else is not trying it. But that's the idea. Okay. So you can also upload data, and that's probably very important if you want to do some real analysis and you have some data stored on your computer locally. You can just press on this upload icon here and upload data. You can also, I'm switching back and forward here. You could also here create a folder called data, for example, and then you click here on the upload icon, and then you can upload data from your hard drive. Right. This is the basic idea of Jupyter. I haven't used Jupyter a lot in the past, and I prepared a lot with Jupyter for this workshop. And one thing that I was always missing coming from an R Markdown background is all the flexibility that you have with R Markdown. So for those of you who have worked with R Markdown, you have these code chunks, and you have quite a lot of control over these code chunks. So you could, for example, hide the code, or you could only show the results, or you could delay execution, or you could cage different code chunks so you don't have to re-execute it over and over again. And I was that's something I was missing from Jupyter. And I found then out that Quarto, which comes from RStudio, it's a development from RStudio, but explicitly it's a Markdown rendering engine that's with multilingual support. So it's not designed for R. It's designed for R and Python and Julia and other languages. So you can think of it as a generalization of R Markdown for other languages. And the nice thing is you can integrate that into Jupyter. So why would you want to use that? You can simplify the integration of code and text within one document. You can create reproducible documents and with much more control over the content. So for example, what I often have in my scripts is I have a first code cell, chunk, whatever terminology you want to use, where you prepare everything, where you load the data, for example, where you load packages if you're working with R, where you set some global variables, etc. And that's something that's of course important, but I don't want to show at the beginning of a report because it's just cluttering. And then what I just said before, you have the ability to have multi-language, so multiple programming language in the same platform. And now Quarto has very nice features. So you can take your Jupyter notebook or your they talk more generally from a Markdown file and export that into different formats. So you can export it to HTML, PDF, Word documents, so you can also do presentations. Underlying is as the engine is called Pandoc, which you probably have heard with if you use this reproducibility, if you've been in the scene for a while. It's very reproducible, and also you could say it's very fair because it's based on a text file that you can easily track using GitHub. For scientific purposes, it's also very, very nice because you can do referencing in there. So there are two two types of referencing. You can reference different sections, figures, or tables. And you can also include a bibliography, so references to other papers. And that's something we like to do all the time. So, and its integration with Jupyter, for me, it was kind of a game changer because you have much more flexibility about your code cells. So here's an example that I took from the Quarto website. And you start off with putting a header. That's something you're probably familiar with. They recommend doing that using the raw cell type. But you could also use it with a markdown cell type. So you can then give it the title of your document. Then you can get a lot of formatting instruction here. For example, if you say TOC, so that's table of content is equal to true, it will automatically generate a table of content. I also added here embed resources is equal to true. What that does, if you render your Quarto or your markdown file to an HTML file, it will be a standalone HTML file. That means it's one file and all your resources are included in that file. And what is important for Jupyter is that you also define the engine here. So which kernel, which programming environment do you want to use? Here we say we want to use R, but you could also put Python or other languages there. So then you can add markdown cells as before, but you can also use cross-reference. So here, it's really just from the example, but you say here for demonstration of a line plot on a polar axis C, and then you reference at figure polar, and this will then be changed upon when you compile that to figure 1, figure 2, whatever figure that is. So if you then come to your, if you decide to add another figure before that, it will automatically update the numbering and everything. Then you have a lot more control over code cells. So I'll just do that here. That's actually a Python example, so I didn't pay attention. So this and this doesn't match. If you want to do Python, then that should be Python here and not R, of course. But the idea is the same. So you put in front of your code a hashtag and a pipe for R and Python. So that's the command for a comment. And then you can specify here what is happening. So you give this code chunk a label, and that's fig polar. And so you have here, you see the connection here. You can also give a caption for that figure that is automatically placed under that figure. And there's many other commands you could put here, many other chunk options. So you could, for example, add something like echo is true or false. Echo means, do you want to plot, not to plot, to print out this code or not? So you could hide, for example, the code that is needed for generating a figure. If it's a report, that's probably what you want to do because most people won't be interested in your code. If it's teaching material or so, then you probably want to show the code. So for students to be able to follow along. Right, and finally, what you have to do if you're in a Jupyter environment is you have to render your notebook. And you render your notebook by using Quarto, and then you open a terminal. We'll see later how you open a terminal. And then you just render that from the terminal. And what you would type in would be Quarto render, and that's just one example for Jupyter Notebook. And to what formats do you want to render that? You want to render it to an HTML, docx, and a PDF. So I did all three of them. You could do, of course, only one of them. And there's a really good documentation. that you can just go and look through it. So it's very powerful. You can do a simple document, but you can build whole presentations and websites using Quarto. Okay, are there any questions about that? Then we have the second big chunk, which is Git and GitHub. And this can be, admittedly, it can be confusing, especially if you start interacting with Git and GitHub. But we'll try our best. And if you're lost, feel free to interrupt. If it's small things, we can try to figure them out. And again, I'll encourage you to try to do that as we go. So, what is Git? And I think most of you have used it. It was like at least half of you. So Git is a version control system. What is a version control system? And that builds up on the idea that Ivo presented earlier today. So you probably have seen something like this. So you have manuscript version 1, version 2, version 3. Often there is then a version final and a version final with 1 exclamation mark and a version final with 3 exclamation marks. So that's kind of a naive version system where we want to have different versions of our works, of our manuscripts, of our code saved in the case we want to go back to something, in case we want to see what we did before. And the idea of GitHub is, or of Git, I should be more precise, is to do in some way the same thing. So imagine you have a file here and you put here milk and then you add X and then you have version 2, it's called revision 2 here. Then you add juice, you have revision 3 and you have you remove juice and you add soup and you have revision 4. So you could imagine you have version 1, 2, 3, 4 here, which is a nice thing, but you shouldn't do. So the idea is that you can you just have the latest version, the latest revision, that one, and if you want, you could go back, or you could at least check what was the difference here and here. And if you have something like this, it's not always obvious what are the changes. So what did you change from manuscript version 2 to manuscript version 3? So you would have to open the files and start comparing them again, and this could be tedious. Okay, so what is the idea behind Git? Is to think of Git as a program that saves the state of one or more files at a given point in time and enables you to go back. So you have a file, you have multiple files, and you work on them, and you say, well, now I have a milestone reached. I want to freeze that as it is, and then keep going on. In Git terminology, it's saving a file. Files is equal to you commit your changes to a what is called a repository. And a repository or a short repo, that is something that is being tracked. So you could also see it like this. So you have a repository, and here you have several files, and you commit those files to the repository, then you have version 1. Then you do some changes, you add some files, you modify some of these files, and you commit that again to a repository, and what you have then is version 2. And Git allows you to go back to version 1 and see what are the difference for each file, for all the files between these versions. And then there's the thing of GitHub. So what is GitHub? And GitHub is basically an online platform for Git, for collaborative coding, so that enables you to share your repositories with others. So you can think of it like this. Git the technology. So Git is a software and GitHub is a service to work with Git more efficiently. And there are several, so it doesn't have to be GitHub. It could be GitLab, and there are others. So there are other services that try to enable collaborative coding using Git as a technology. Right, that's what I just said. So GitHub is one place, but there are many others. GitLab or Bitbucket. Some organizations also provide their own instances of not GitHub, because I'm not sure if GitHub is open source, but of GitLab for sure, or Bitbucket. For example, in Göttingen, again, the GWDG has a GitLab instance, so you could collaboratively code using GitLab. So the thing with Jupyter is, or with Git and GitHub, is that you're often either you use the command line or you use an extra program. With our Jupyter instance, what we want to do is we have to use the command line, and that's this symbol here. That's the terminal window. And if you're in your Jupyter instance, you can click here, and what you get then is a command line window with that. So it's a Linux terminal, so some of you may have used that. Many of you probably haven't. And it's basically, it's a way to programmatically interact with your computer, or with your Jupyter instance. So the first thing, what you usually want to do is to tell Git who you are. So that if you do a commit, if you look at the commit history, etc., that there's a name printed here, and then it's also important to have an email address, and that should be the same as you used when you registered with GitHub. So what you can do is you open your command line, and then you type git config -- global. So it's always the same for this machine. Then username is, for me, it's Johannes Signer. Email address is jmsigner@gmail.com, because that's my Gmail address, and that's the address I use for GitHub. And then if you did that, you can check if it really worked by git config -- global -- show, I think was the example. So you could try to do that now, or you could also do that later, depending if you're one of the lucky ones who were able to get into Jupyter. Right. Once you did that, you want to initialize a repository. And the thing is, in the command line, what you do is you always write git. That means you're talking to the program Git. And then you define commands. And here it's the init command for initialize. So here is, again, the terminal window. ls -a shows you, ls is for list. And ls -a says then list all files, also the hidden files. These are files that are hidden, that you have explicitly just say, I want to see them. And if you do that here, you see there are two files. One is a dot and one is a double dot. That means go one file up, one file down, so they're not really files. And if you do git init and you list again, you see there's also a .git directory. And that means there's a repo initialized, and you can now work with that. So I see that there are some messages in the chat about the server. Okay. So Daniel replied that they're restarting the server. So maybe we'll have more instances soonish. Right. So that's the part of initializing a Git repository. The ls and ls minus a is just here to show you that actually something is happening. So the basic architecture behind Git is that you have a three-stage, three building blocks. So you first have the working directory. These are your local files. And then you have a part which is probably somewhat confusing. It's called the staging area. The staging area is basically the area, if you think in terms of a real-life example, where you work on some items you do here, and then you say, well, let's imagine you're a carpenter and you're designing chairs. You're building chairs, and you build your chairs here. Then one chair is finished, you're putting it to the staging area. And once you said, well, this batch of 6 chairs is finished, I want to pack them and ship them away, then you take everything that's in the staging area and you ship it or commit it to your local repository, right? So you're working on a file, and at some point you say, well, I'm done with that file, I add it to the staging area. Then you work on a second file, and then a third file, you all put them together, the second and third file to the staging area. Once you're finished with your task for this morning and you're happy with that, you commit everything from the staging area to your local repository. And once everything is in your local repository, you probably want to share it with others or to back it up remotely. And that is when you move everything from your local repository to your remote repository. And the remote repository is, for example, your repository at GitHub, GitLab, wherever. So these 3 parts happen locally. This one, you need internet connection to interact with your remote repository. So, right. You could also see it like this. That's your working directory. That's the staging area. It's also called index. That's your local repository, also called history. And then remotely, you have your remote history. To initialize everything locally, you have to run git init. We already did that. So that's creating here everything you need locally. Git add remote is to add a remote repository. That's something we haven't done. So let's look at a very, very simple example. And I create a text file with called fruits, and we have an apple in that text file. So I again use the ls command to list what is there, and then I use the echo command to echo something, to write something on the command line. And you can use this nice larger sign to divert the output from the command line into a file, and I just write that into fruits.txt. So everything that's happening is I write in a text file called fruits.txt one line called apple. And if you want to see what is in the file fruits.txt, you can use the cat command to print this file to the command line again. So we have this file, we use cat fruits.txt, and then there's apple. So that's just very, very simple text file. If I'm now happy with that, whatever is in that text file, I can add that text file to the staging area. And what I do is to call the command git add and the file name. So in this case, it would be do 2 things. I start with git status. Git status gives me the current state of my repository. If you do that, git status, you see no commits, untracked files. So the file fruit.txt, it recognizes there is a file, but it's not tracked. So it's not added to the repository. So what I do then is to call git add fruits. If I look at the status again, then there is a new file called fruits, and that's it. So it's in the staging area. And if I want to move that from the staging area to my local repository, I have to use git commit. And there's also, I'm just going to open that here. There's also an argument -m. And so git commit -m, m is the comment. So I can, or I have to always say what changed with that commit. So often you see something like it's an initial commit. And if you look at that here again, so what I did here is git commit, or I check the status again. Well, it's a new file, then I commit -m, and then initial commit, that's the commit message. And now it said that it committed something and git status nothing to commit on the master branch. So that's all good. And we committed that. What we often, or what sometimes is being done, is that we skip the staging area. So if you just do a small fix of something, or you just know you're just editing one file, you do git commit -a. A means to add it as well, and then you can type here the file name, and there should be an A and an M. I have to change that because you also want to commit with a message. So with the commit message, but then you don't have to put the files into the staging area. So if you have something in the staging area and you want to restore it, that means that you unstage it. So for example, let's have it like this. With git restore, you can take something from the changing area and override local changes. So in our case, we can do it like this. We take our fruits document, we add a kiwi to the fruits, and are using this double larger sign here. That means I'm adding a new line. I don't override it. So we have apple and kiwis in here. Then I check for the status, and it says fruits have been modified. I add fruits to the repository, to the staging area. And what I do now is I look again at fruits. So what is in there? So it's apple and kiwi. And now I add, for example, banana as well to my fruits. But that's only locally, it's not staged yet. So if you look at that, apple, kiwi, banana, and we want to go back to whatever is in the staging area, that means we undo the last changes. So we can just say git restore fruits.txt. And what we see if we execute that again is that the banana is gone and we're back to that version that was in the staging area. Okay. Then, if we are kind of happy with our local repository, we can try to push to a remote repository. And pushing to a remote repository requires a little bit of work upfront. So what we have to do is we have to set up a remote repository, and we have to generate a key pair for authentication. So to create a new repository at GitHub, you should go to github.com and log in. So that's what I did here. And then you see here, you click the plus and add a new repository. I called it NFDI for biodiversity T1 for test one, and I made it public. You could also make it private. So if you make it public, you have to be aware that everybody who knows the name of the repository, and that's not hidden anywhere, can access whatever is in that repository. So that should be probably something in a final stage or something you're happy with other people seeing. You can also make a private repository, so that is then protected from the public. Then this is maybe a little bit a tricky part. You have to do some authentication when you want to push from your Jupyter Hub, from your, what is in this case the local repository, to the remote repository. And the easiest way to do that is to use an SSH key pair. And that's an asymmetric encryption method. That means you have a public key and a private key, and the public and the private key, these are just long strings of text and numbers. And the public key is the key you give away, and the private key is the key you need to protect. That's why it's called the private key. And the private key sits on your Jupyter Hub or on your laptop, wherever. The public key is what you upload to GitHub or wherever you want to authenticate. And what is happening behind the scenes, I don't know it in detail, but the idea is that the private key encrypts whatever you're sending, so locks it up, puts a key on it, and the public key then is able to encrypt whatever is arriving using the private key that matches this one public key. Right. To create these private and public keys, there is a program called SSH key gen. Where am I now? So you can go here, SSH key gen, and then it generates a private and a public key. I would leave the default path to that. You can add a passphrase to protect that. That's something that's sensible to do, but I didn't do it here for simplicity. And then the private and the public key are being saved on your hard drive or in the Jupyter Hub. By default, the directory is home, your username. So for me, it's J Signer. For you, it would be students 1 through 20 something. .ssh and then id rsa.pub. That's the public one. And you can type here the path, and then you have the public key here. And you take this public key, you copy it, and then you have to go over to GitHub again. And when you're in GitHub, at GitHub, you click here on your profile on the top right. Then you click on settings. That's where you can adjust that. And in settings, you click on SSH and GPT keys. And if you have done that, you click here and you say you want a new SSH key. And if you click here, then this window appears. And here you can give the key a title and paste the key what you have in your clipboard. That's a bit tedious, but the good thing is you have to do that only once. And then you have a connection between GitHub and your Jupyter lab from your Jupyter Hub. go back to your terminal, you add the remote repository, you use the git command git remote add origin, and the origin is, so that's the remote repository. It's called, it's by default, or it's a commonly used the name origin, but you could use a different name. And then you have here the link to your repository at GitHub. Once you do that, then you can type git remote -v to see if it works. Then what you have to do, unfortunately, and we don't worry about branches here any further, but you have to create a new branch for your existing repository called main, and you can see branches as different versions that come together again, but that's something you just execute once, and then you can say git push origin to main, and then you have in your remote repository, you have everything, the current state of your local repository. So that's kind of this step of pushing everything from your local repository to your remote repository. And then, of course, what you can do as well is your remote repository, you can pull it back to your current local repository, or you could clone it. So to pull means you have already an installed version. You already have the repository, and to clone means you're on a new machine or you're in a new directory and you want to get that repository back. So what you could do is to get to GitHub and edit the file directly on GitHub. So you can do this. Just click on this pencil here. Once you did that, you can add more content. So I added bananas again here. And you then click on commit changes. Once you did that, you can give an update, a commit message. You commit these changes. And back on Jupyter Hub in the terminal windows, I then just press enter in the terminal git pull. And what happens is that fruit.txt is updated, and you see there's +1. So that means there's one new line. And if you cut to concatenate fruits.txt, what you see is that we have the bananas back in our local repository. Right, and the same thing with git clone is the question, why version control Git from Jupyter instead directly from RStudio? This is a good question. There's nothing wrong using Git from RStudio. The thing is that Jupyter is a bit more. I know you can host RStudio also on a server and use RStudio server, but you're still kind of confined to RStudio. But if that's your workflow, I think that's perfectly fine. If you use what we are illustrating here is just to use Jupyter instead of RStudio, and then you can use GitHub from Jupyter. In fact, the way we're using GitHub here is much more generic, so you could use that in any directory in your on your machine or on a server to just track the files that are there. Okay, and then the other thing to get data from a remote repository was git clone. And if you want to have a local copy or a clone of a remote repository at a different location, machine, whatsoever, you can use git clone. And I'm changing again here. If you go to, for example, that's the NFDI GitHub repository here. And if you click here on code, then you see here for clone, you can just copy that here and clone that wherever you want to have that. So here I cloned it in a different repository, in a different folder, sorry. And I type git clone and I just copy pasted the address. And then I have everything in that directory. Of course, there are some restrictions. So you can only clone a public repository or a private repository that you are part of the team, right? You can't clone any repository. Okay, are there any questions about Git and the idea of that?
Yeah, thanks. So just to compare or to make it more understandable for my daily workflow, and I think maybe it's comparable to your daily workflow. So when you work, for example, on an analysis, you do some modeling in an R script in RStudio, and then you want to back up your work for the day. You wouldn't put that to the staging. Phase. You wouldn't do that, or how would you? Where do I put it? I didn't really understand that part.
Yes. So what I would typically do is so if you decide to try, you use GitHub for your project, and then let's say your task is analysis for the analysis is to create these 3 plots, and then you're happy with these 3 plots, then you would do a commit and say create a plot 1 through 3, and you do a commit, and then you do this commit to the and then you can push this to the remote repository, and then you're done. So the staging area, I honestly don't use it very much. Whether or not that's a bad thing or not, I don't know. So I usually just skip the staging area to do that.
Yeah, thank you so much. I was wondering if, for example, I already have my folders with my codes, and it is possible to upload everything to the remote repository.
Yes.
When I already have a bunch of files.
Okay, so you're saying you're having remote and local files, and you want to merge them together?
Yeah, so I have normal files when I'm normally working, and I don't have any repository yet. But
yes,
if I want to start using it, so but the terminal, I can do this local repository, but then I can put it in the GitHub, all the files I have at once,
yes,
or I have to do
No,
something.
you can do that at once. So if I understand you right, the scenario could be as follows. You have on your laptop, on your local drive, you have some files that belong to a project. And what you could do is to go to github.com, create a new repository, and put everything from that local, also all these local files into that repository. And then if you decide for some reasons you want to use a Jupyter instance somewhere else, what you could do then is go to the terminal in the Jupyter instance, clone everything from your remote GitHub repository, and then you would have everything in your Jupyter instance that you also have locally on your laptop. Then you can adjust the files, analysis, whatever, in your a Jupyter lab instance. You push it back to your GitHub repository, and you could pull it again to your local instance on your laptop. Does that make sense?
Yeah, I follow. Yeah. Okay. So that means that my files that I have now, I can later delete it.
Yes.
Yeah.
You can do that. And I should also add here, really, we just scratched the surface of Git. and you could probably talk a whole week or more about Git. Not me, but somebody else. You can do a lot more, but I hope that this will enable you to get started.
Can I do another question?
Sure.
Is how that you also upload your raw data in this remote repository, or is just for files and code?
I would say it depends. It depends on the amount of data you have. So if you have maybe 2 text files with, I don't know, a couple of hundreds or thousands of measurements, then I don't see any problems doing so. If you have terabytes of data, or even if it's only a couple of gigabytes, it's probably not the right place to store the data any longer.
Another small question, sorry. If you, for example, I am already also using Nextcloud to save my files and have a remote backup. There is a way to integrate this with GitHub?
Oh, this I don't know. But I understand that Nextcloud is a typical cloud service, I guess. And so there might be some versioning in that, but I guess they're kind of, they have different target audience. That's my best guess.
Thank you.
Yes, I have another question. I don't know if we're gonna mention it in the future and during this course, but I have a question about GitHub and the branching. Is it better to work with branches or to work always in the in this main branch?
Well, typically, so the idea of a branch is that you have your release version or think of an R package. So you have the version that's at the moment out there, and then you want to work on some features, and you don't want to touch all the code and get in danger of breaking everything. So you do a branch, and the branch is kind of a copy of the last working version, and then you can do some experimental stuff on that branch. And once you say, well, I'm happy with that, I want to merge that back into the main branch. And usually this is then then you can do some tests and see, does it break anything in the main branch? And if that's not the case, then you can merge a feature in the main branch. If that's something you're doing and you feel confident doing, I don't see why shouldn't you do it. So you could, for example, what could be an example? If you're doing some type of modeling, and then you think, well, that's probably the wrong model I used, but the results are okay. Let's try a different model. So I have to adapt several things and then see what the result is. And depending if you think that's better and that's what you want to use, or you have 2 ideas and you want to have competing ideas and test them at the same time, you could do that on different branches without breaking your branch that actually worked. Go ahead.
Yeah, I would have a question. If you have, for example, data which was shared with a data sharing agreement and which is kind of sensitive, do you have a best practice how to divide, for example, working directories, or like having the code accessible in a remote environment, but having the data locally versioned with Git, for example?
So that's if you're worried about the security of GitHub?
Yeah, kind of. Like, not being worried that the data which was shared.
Yeah. So some institutions, so I just know from Göttingen, GWG, they host their own instance of GitLab, which is very similar to GitHub, but then you're sure that your data stays within your organization. And as Ivo suggested before, ask your IT department if they have some instance of a GitLab or so that is hosted in your institution or on your institutional servers. Okay, then I think we're right in time. What I wanted to conclude is, so Jupyter and Quarto, I think they play together very nicely. I only discovered this symbiosis by preparing for this workshop, and I haven't tried it myself, but I certainly will. GitHub is something I use quite frequently or every now and then in my everyday life as a researcher. And you will see later by Ludmila, I think it's tomorrow or day after tomorrow, how you can take your GitHub repository into an executable environment to Binder or my Binder. This is most of what I wanted to say. I added at the end some of the commands that, or most of the commands that we used. I don't know if you never used command lines before, then that might be a bit of a lot of at once to start with, and you probably don't see always the point of why would you do it like this. And also for Git, here are some of the commands that we used. Again, I want to emphasize that was really just the basics. There's a lot more you can do and you should do when you start using Git. Otherwise, I would thank you for your attention.